Afternoon, all. So as I've been introduced already, my name's Ollie. I'm the electricity storage network lead, and the electricity storage network is there to be the voice and industry body for grid scale storage. And so I'm going to be taking you through this section. So the place to start really is why do we need battery storage, and particularly kind of in light of Clean Power 2030 and some of the ambitious targets we've already talked about. So there are kind of two buckets of benefits here. So consumer benefits and system benefits. Not going to go through all of them. I think the bottom line, really, from our perspective, is that battery storage can really enable more renewable energy to come on the system. It's a kind of a key provider of that flexibility that we need, shifting the power to when people can use it, and in a kind of when we have kind of variable renewable energy generation on the system. Drive down bills in terms of kind of particularly replacing more expensive gas-fired power stations in key system services. So that's kind of been a really positive role for battery storage already. And I think the kind of key one that I always like to highlight is that it's already playing a really critical role in keeping the lights on. So in a kind of disturbance on the network or on the grid, normally caused by a kind of power station tripping off or an interconnector tripping, that disturbance, it kind of all of the battery fleet currently responds to that disturbance and keeps the frequency within the limits that the system operator need to maintain. And that in turn makes sure our lights stay on. And this is kind of one of the most critical services on the system. And this is one thing that battery storage is incredibly good at. So some really critical role in terms of energy security as well. To give us a bit of a kind of regional snapshot for the Northwest, so we've got here 16% figure for kind of in terms of the current current share of England's operational BESS capacity, and a fair amount through planning already. So 1.1 gigawatts over the last couple of years. So I'm sure you as planners and your departments have been relatively busy with all of those applications. And that's definitely something we're seeing across the country. There's around over 80 gigawatts of sites with planning across the country. And the main driver of this kind of really big pulse of projects trying to get planning over the last couple of years has been the connection reform process. So this is a kind of once in a generation opportunity to kind of reassess the queue of projects. So the queue of projects looking to connect to the grid really ballooned, far too large, over 700 gigawatts at one point. And the idea with this grid connection reform process is that we really identify what is ready to connect and what is strategically aligned and what do we want to connect as well. And the ready aspect, how developers manage to get the kind of a key part of their readiness criteria, readiness evidence is to get planning. So there was a kind of really strong push for developers to get planning, and battery storage is probably the one technology that's really maximized the potential for getting planning in a very short space of time. So it's put a significant amount of pressure on the planning system, and I think that's just but I suppose the kind of the bottom line from a planner's point of view is that hopefully you're already seeing this is there will be a much lower level of battery storage applications coming through over the next few years compared to the last couple, which we've had a really kind of strong pulse projects. Next slide. So yeah, within the guidance, we've got a number of kind of graphics in there to give you a rough idea of what a battery storage site has included. This is slightly different to ones you might see in an application. So this is kind of side on, and there's obviously similar aspects of any example battery storage project. So the kind of battery cells are within containers or cabinets, depending on the hardware choices made by the developer. You've got the power conversion systems, which include inverters, transformers, and others, and some other bits on site. So When we talk about these types of projects, these are kind of lithium-ion battery storage projects connecting at scale, as I said, 5 megawatt plus. And yeah, we already had a number connected to the system. I mentioned that around six, actually just under 7 gigawatts now, over 130 sites, and but very ambitious targets in ahead of kind of Clean Power 2030. So 23 to 27 gigawatt target there. We've got another graphic here from another angle, which I'll just mention as well. So this provides a kind of a very high level illustration of what could be included in an application and the kind of key components of an application on a battery storage site. Yeah, and there will be significant differences depending on the choices made, the hardware that the developer decides upon, their site location, lots of kind of potential differences depending on the site, but this just gives you a kind of an overview of what you might expect. And yeah, as I say, there's more detail on each of these components in the guidance, so you can get more of a technical breakdown in there. Next slide, please. So we've talked kind of broadly in those two graphics about standalone battery storage. So this is kind of like an individual site connecting to the network. There are two other kind of key use cases that I wanted to go through briefly, which are pretty critical and are relatively popular, depending on which one we talk about. If I start with co-location, so this is obviously the idea where you have a battery storage site, and then alongside it you have a solar farm, ground-mounted solar PV site. So this links to the kind of the next section in the agenda around solar PV. Many projects are planning on having kind of a battery and solar next to each other. That's the most popular mix of technologies, but there are other sites coming forward with kind of a mixed use sites, potentially with data centers and others as well. So there can be kind of different types of co-location. And the main benefit there is you have a shared grid connection, so you reduce the impact on the network, and you can also reduce the losses depending on how it's structured, so less electricity losses, which is a benefit to the system. There's a huge number of projects like this already out there. We've picked one as a case study here, which is Cleve Hill, because it's one of the largest. So the 370 megawatts of solar is already operational. And then alongside it, through 150 megawatt battery storage, those two sites together will be the largest in the country when it becomes operational. So the 150 megawatt battery storage bit is still in construction. And this did receive quite a lot of column inches at the time because it was rejected initially by the local council, Swale. But was successful on appeal, and this is the battery storage element of the site rather than the solar park element of the site. So this just gives you a bit of an idea of what those kind of sites might look like, and yeah, you can look at that website for a bit more detail on what a very large co-located site might look like. But there are different sizes that have come through. Long duration energy storage is a kind of another aspect. So the kind of normal duration of sites that are coming through at the moment, maybe kind of 2-3 hour, maybe even 4 hour duration when it comes to battery storage. And that is in relation to the kind of power capacity. So at full import or full export, how many hours can it kind of last continually, which is not normal operations. It just gives you an idea of kind of the energy capacity versus the power capacity. So, but it does have kind of an impact on the size of the site in terms of the energy capacity, the duration. So that's why I'm mentioning it there. So the long duration aspect is that the government, alongside Ofgem, have come out with a new cap and floor scheme, which is a revenue support scheme in trying to incentivize new projects with significantly longer duration than the market supports. So this would be 8 hour plus. So these kind of projects would be pretty critical, particularly dealing with kind of low wind periods. And they can also help with kind of constraint management in kind of key areas. Lithium-ion battery storage has been very successful in the initial rounds of this project, of this sort of window one of the cap and floor, with around 48 projects going through, or out of 77 to the latest stage. Not all those projects will actually get built, and the final awards will happen this summer. And the reason we're mentioning it here is there are projects going through the planning system at the moment, which will either want to change the existing planning permission they have, or they're becoming with a new planning permission, which will look significantly different to what a normal or a standard duration lithium-ion battery storage site might be. And we've got a case study there from one of our members, Statera Energy, which got planning consent for a 500 megawatt, 8-hour duration battery, which they've bid into this cap and floor scheme, and are hoping to get a contract from, an award from, in the next few months. Next slide. So one of the kind of the more tricky areas and more contentious areas when it comes to battery storage is fire risk. I'm sure anyone with any experience of a battery storage application, this has come up because it normally is a large part of the application, and it can come up as a kind of a key public perception issue. I think the first thing to say is the industry takes this incredibly seriously. There's a huge amount of technology and design and particular hardware in order to kind of mitigate any fire risk on the site. These sites are expensive to build, normally kind of hundreds of millions of pounds of investment. And there's been a lot of work across the sector, particularly with the insurance industry and other kind of international standards and bodies, to minimize that fire risk as much as possible. The incidents in the UK are relatively rare, so we've got some figures on the screen there, kind of indicating how rare these fire incidents are on battery storage sites. And when there have been incidents, they have shown successful mitigation. So normally, successful mitigation means that perhaps kind of one container or one unit might have a thermal runaway event and cause a fire, but the design of the system means that hasn't spread to other units on the site. Got couple more slides on fire risk, because it's quite a chunky subject, and I would definitely encourage you to have a look at the guidance sections on this, because there's some really good information in there. In terms of the kind of the governance of fire risk, so the planning practice guidance has a recommendation there for developers to have regard to the National Fire Chiefs Council guidance. And that guidance, which was initially published in 2023, was actually updated on Friday last week. So I've got a slide on that in just a second. But just to be clear, that guidance has got some significant changes in it. So the industry is just still digesting some of the changes within there, and we'll put a link into the chat as well, so you've got it for reference purposes as well. So yeah, the industry and developers have to have regard to the National Fire Chiefs Council guidance. But I think it's fair to say the general regulatory framework for health and safety is overseen by the Health and Safety Executive, and there are several regulations that are set out on the HSE website related to battery storage, and it's mainly the responsibility of the owner and operator to adhere to this framework. The planning practice guidance also suggests that you should be engaging with with your local fire and rescue services, and that is something that our developers have been doing and our members have been doing, and I know Field have been very active, and we'll hear from them shortly about doing that. And in terms of kind of how the planning system and the fire and safety, product safety and health and safety regimes interact, there's a table here to try and explain that, but the overarching summary really is that the planning authority is there to determine that appropriate guidance has been followed and risks minimized to as low as reasonably practicable. they're not necessarily able to kind of assess whether the specific kind of fire risk mitigations on that site are correct. They are there to assess whether they've taken into regard the new National Fire Chiefs Council guidance, for example, or some other kind of international standard that is relevant here. So hopefully that's clear, but there's lots more information on this in the guidance. As I mentioned, so there's brand new guidance, came out on Friday last week from the National Fire Chiefs Council. It's a really good shot in the arm. The industry's been waiting for this for a number of years and has made some really significant changes as to how fire risk is treated within that guidance. There are three key bits that I thought I'd bring out for planners that are particularly relevant to planners. The first of which, there was a suggestion within it that there should be a clear line of communication between planners and the local fire and rescue services, but also clarity that they're clearly not a statutory consultee. So there is that aspect to it. So perhaps kind of local fire and rescue services are commenting on sites, but they're not a statutory consultee. The second point there is that planners and developers should definitely be engaging with the local fire rescue services, and the new guidance sets out requirements or suggestions for local fire and rescue services to have a kind of key contact for battery storage, and also kind of like a web page with some information on it on their fire and rescue services website, which is a kind of positive step. And the final point there is that it specifies that the guidance should not be seen as a mandatory set of recommendations for any kind of planning or application. And very much the local planning authority should be looking to kind of have that open discussion with the local fire and rescue services, and not just look at the kind of guidance for a kind of specific set of requirements. So I'll put those two links. There's a link, and then there's also a really nice summary of changes between the 2023 and 2026 version. I'll put both those links in the chat in just a second. On noise, it's fairly clear cut. There's some existing policy available. The general gist of this is that there are abatement technologies out there, some buffering in terms of kind of trees or shrubbing, in terms of planting. There are kind of acoustic fences used by some developers, depending on the site, and obviously noise can be an issue because a lot of these sites can be rural with a relatively low background noise. But there is a pretty clear set of statements around this and particular regulations. Slides. In terms of landscape and visual impacts, battery storage generally is quite an energy dense technology. Sites don't tend to be that large, although we do see in the planning system some pretty large sites going through, and there is a trend towards larger sites generally, just kind of as the industry has matured, scale has become more and more important. There aren't any specific kind of planning policies towards battery storage in terms of kind of landscape and visual impact. So it's generally treated as any other development under the Town and Country Planning Act. And the kind of visual impact is relatively minimal in terms of the kind of the battery containers tend to be around 3 meters tall. Some can be slightly higher. The substations and transformers can be a bit higher than that, so maybe 6 or 7 meters tall. But as you can see from that graphic, this is kind of a really good example of how minimal the kind of impact on the environment and landscape can be. And I'll just pick out that some developers have been using kind of green battery units, but that's not necessarily the norm across the board. But in this instance, it looks quite good in that landscape and in that surroundings. And some good screening on in terms of vegetation on this in this example as well. And lots of developers use planting in order to help with the screening and visual impact.
Hi, I'm Emma. I work for Field. We are a developer, owner, operator of BESS sites. We have 6 operational sites across the country and 2 more in construction. We exclusively work on BESS projects, so this is very much our area of focus, and hopefully therefore expertise. So I thought we'd take you through today a bit of a case study of a project that we've recently received consent on, and kind of the work that we've been through with the local council on negotiating specific elements of the projects and key areas that were of interest. So the project we've got here is a project called Spittal, and this is a case study from the Scottish Highlands, right up north of the Scottish Highlands. So the project proposed is a 300 megawatt 2-hour duration site. It's located strategically immediately adjacent to the substation to which it will connect. So I guess key locational drivers for a battery are proximity to a point of connection, which normally would be a substation. So that's something to kind of draw your attention to. This specific project, we've proposed a new access road and junction onto the A9. And so those points of access and ensuring we've got suitable construction access is also a really key point for one of these batteries. And then landscaping, we've used bunding in this project to screen views from nearby scheduled monuments, but also from the road. So I think that's a key tool that can be used quite well. BESS units are generally somewhere around 3 meters high. So a bund can be really effective in screening most of that in quite a few scenarios. And on to the next slide, please. So just drawing out a few kind of key topics that are maybe a bit specific to batteries. Abnormal loads are expected with most renewable energy projects, I'd say, and that is batteries are no exception. The batteries themselves are generally delivered on a typical HGV lorry, but there are some components within the substation within the layout that require an abnormal load delivery. This, for example, would be the transformers that you'd expect to see in any transmission level substation. The kind of delivery of those is then via specific vehicles. And I guess at a planning application stage, we would expect to have completed a desktop assessment of the viability of the route, identified the port we'd expect that to be delivered to, as they need to be delivered to the nearest viable port, and then also had a look. We would typically expect the detailed assessment of that process to be completed post-consent, secured via condition, and then it involves quite significant engagement with highways and the police ahead of any deliveries being completed. You're looking at kind of 1 to 3 of these per project, so they are very unusual loads and kind of very specific, but this is kind of one of the key things for us to consider the viability of. A bit more generally, we're kind of typically looking at a 2 to 3 year construction period for a battery of this size. And those construction movements are generally fairly front-loaded into the first half of that programme. The kind of following most of the main civil works and deliveries, you're then talking about electrical testing, commissioning, and energisation. So whilst there still will be quite a lot of work happening on site, you'd expect a lot of the deliveries to have been front-loaded into those first year and a half or so. Thank you. And the next one, please. A slightly different topic would be noise. Noise always comes up with batteries and is a really key issue for us to be working on across the industry to ensure it's managed appropriately. So the typical assessments we'd be looking at is through BS 4142. And the main noise from a battery system is the fans. So the cooling fans that we're operating to keep the batteries at a suitable operating temperature are the thing that generate the noise. That is really dependent on kind of the size of the project, the duration of the project, and how it's being operated. So there's kind of no one size fits all as to which modelling parameters you're using, which can be quite difficult to kind of reach agreement with developers and the councils on what should be modelled. for example, a 1 hour duration project would typically ramp up and ramp down quite quickly several times a day because it's kind of doing it over the space of an hour. Whereas if you're talking about a 4 or an 8 hour duration scheme, it will be doing it a lot slower. The fans are then running at a lot lower effort and are therefore much quieter. So they're kind of not comparable from that perspective. I think the key thing from a noise perspective is to ensure that the fixed limits that you're assessing for the local area are fixed limits. It's then up to the developer to deal with that and ensure that they can comply with them. I think finding a level that's tolerable compared to background or absolute noise levels, and then assigning that condition, it's really then up to the developer to say, right, well, whatever you build in the future, you need to make sure you can meet these levels, and it's their risk to take on rather than the council's. So on to the next one, please. And then this is a really big one. I think we kind of already touched on it, but battery storage is changing so quickly. We originally started looking at the scheme back in September 2023. We were looking at a 200 megawatt 2 hour scheme. 6 months later, 6 months later, we had some new updated information from suppliers. They're innovating very quickly. The scheme's changed and we can now fit 300 megawatts within the same footprint. 6 months after that, in December 24, we were still looking at a 300 megawatt scheme, but the layout within the field has changed a bit. So we're now saying we've got space for some different access roads. In order to position the battery containers where they're going to be landing, we need some different landing pads for the cranes. So I think the nuances of those specific final layouts are really difficult to capture in the planning process. And it's looking about, like, in order to ensure that whatever comes forward post consent, because it's honestly very likely to be different from the consented scheme, it should be within a window that's kind of manageable within some flexible parameters, a Rochdale envelope type approach, or considering how you're best building in some flexibility for those future changes, because it is definitely an expectation that there will be some form of NMA or Section 73 to change what is kind of on the face of it reasonably small changes of kind of 20 centimeters height differences, or same number of units but in a different orientation, or plus or minus 20 units on the site, which kind of don't visually or generally don't have major planning change impacts, but will be different from the scheme that is consented.
I shall move on straight to Francis Nicholson from Harmony Energy. Francis.
Hi, great. Good afternoon, everyone. Hazel, please also shout if you can't hear me at some point, because my microphone seems to be going on and off all of a sudden, but let's just try. Really quickly, I'm just going to run through a couple of examples of sites that we've worked elsewhere in different regions. Very quick overview of Harmony Energy beforehand, though. So Harmony Energy, I should probably point out as well that I'm the development director here at Harmony Energy, so very much involved at the front end of the process and across all the sites that are going through the planning process here. We're a developer, owner, operator of battery energy storage, so ordinarily what we get consent for, we plan to build out and operate and maintain out the back end. We are headquartered in Knaresborough, but ultimately we've branched out and we've got operations across Germany, Poland, Italy, France, and then we've got some solar in New Zealand as well, with an overall pipeline of 13 gigawatts. You can see here on the maps before you that there are a number of projects up and operational across the UK. So we've got 18 sites now operational, one in France, but the rest of them, the 17 of them, in England and Scotland, and with a further site in Richmondshire area, which is under construction. So that's our Skiby BESS, where you can see in number 14 on the plan. So that's a very quick overview of our experience, how we operate, what we do. So I'll just get on to straight to case studies. I'll get onto a plan in a second, but I just wanted to touch on one of our sites in South Derbyshire, actually near Burton-on-Trent. It is consented. It's a 200 megawatt 4 hour system. So Ollie sort of mentioned that ordinarily you get 2 to 3 hour systems. We have got a 4-hour system consented in Burton-on-Trent. It's a transmission connected project, so I'm pointing that out because obviously there are 2 layers to the grid. At a distribution level, you'll normally find the smaller scale projects. We're at a transmission level at 400 kV here. So that means that ultimately connecting into transmission level electricity networks require the schemes to be much more larger in terms of their scale to overcome the colossal grid costs. I've pointed out there some of the grid costs. So this also includes the connection to the grid in terms of the infrastructure that we need to build on the site, like the switchgear and the transformers, but including in that, the cabling can be up to £10 million per kilometre. And ultimately, grid costs are crippling to a battery development. So, you know, we get a lot of questions about proximity to the grid. Why can't we be located elsewhere? And I'd say the primary reason is that we need to be as close as possible to that point of connection, because the grid costs can absolutely cripple the project. For a project of this scale as well, it's about £200 million in total capex. So what it costs to order the transformers, the grid, all the batteries themselves, the civils, the groundworks, everything involved, plus, you know, the landscaping and all the good work that we do in terms of habitat creation as well. This particular site was quite neat to a lot of sensitive receptors, actually. We had a new build housing estate opposite it and individual properties all within about 150 kilometres, I wish, 150 metres. So we had to be very careful in terms of the assessment work that we did in terms of but predominantly noise as well. Batteries obviously don't make the noise themselves, but it's the cooling systems on top of them. And we also can't forget the grid equipment as well. You know, it has got that lower frequency hum to it sometimes. And just pointing out at the bottom that battery energy storage systems, they're not built with a government subsidy. So we really have to stand on our own 2 feet. So without taxpayer support, without that sort of hedged electricity price that, for instance, solar can apply for through the contracts for difference, the CFDs, the results actually just out today. They really have to stand on their own 2 feet because we are at the behest of the volatility of the electricity network, and it's called at merchant risk. So all with that in knowledge of, I'm going to get on to the next slide, please. So this is the site in question, little red patch on the page there. I think it ended up being about a 20-acre site in total with about a 10 to 15-acre development footprint. I've circled it there and done a lot of assessment work, as quite often we have to justify the location. And to be honest with you, it's us, is what we want to do as a developer, to justify the location of why we are in, you know, why haven't we been able to go 10 kilometers down the road when ultimately there could be a perfect bit of brownfield land? Not that that ever exists these days. Low-hanging fruit's gone. Why do we have to be so close to these residential properties, which you might see there in the sort of peachy coloured, I don't know, if a little, yes, well done. Yeah, whoever's wiggling the mouse there. So that's where the new build housing estate is. The grey area just to the west of it, that's where the big 400 kV Drakelo substation is. And there are a number of other renewable energy projects in the locality which are connecting into that as well. You can see, though, obviously with the red patch and where we are, it would be great if we were just down the road, but there are a number of other planning applications. There's almost sometimes a bit of a toss-up between, well, do we want to sort of extend into the open countryside as much, or do we want to try and keep as close to the urban conurbations as possible? And sort of in doing so, clearly we think quite deeply about the design aspects early on. You know, we do not want to just dump battery energy storage systems in the middle of a field without any mitigation whatsoever. So really we should be looking out for things that you can do on the site to try and screen the schemes from day one, and perhaps not even just relying on tree planting, because we all know it takes a little bit of time for trees to grow. So I can get onto that in a second, but you can see that we did do an assessment around the site. That's actually a 1 kilometre radius. In this particular instance, And as a developer, we only progress sites which are within about 1 kilometre of the point of connection of that substation. You might get some other developers which have slightly wider parameters, but we keep to 1 kilometre because, as I mentioned, we are at the behest of the volatility of the electricity networks, or the market rather, I should say. We don't get a government subsidy, and as I mentioned, those grid costs can be absolutely crippling. And so as a result of our strict site finding criteria being as close as possible to the point of connection, everything that we've got consent for to date, either via divestment or that we've built ourselves, has actually got built. And that's not always the case across the industry. A lot of projects are perhaps ill-conceived, where, for instance, the grid costs aren't factored in as rigorously as they should do from the beginning. Something that just needs to be understood, I suppose, a little bit from a local planning perspective, local planning authority perspective, that we need to be as close as possible to the point of connection. That's probably the main guiding principle. So just on to the next slide, please. And so in this one, unsurprisingly, we got officer support, but then it was refused at planning committee based on impacts on agricultural land, would you believe? So not landscape and visual being so close to residential properties, not noise, not any other sort of residential amenity issue, actually impacts on agricultural land. And you can see that this is a photo montage that we had mocked up during the course of the determination, and ultimately it was allowed at appeal. So you can see that quite substantial sized grid infrastructure to the west of the site. That's the switchgears and the transformers, and then a cable would run to the Drakelow substation, which is just on the opposite side of the road to the west of the houses. As you can see, there are some of the key benefits too. We've put all that planting in at the front of the batteries. As Ollie mentioned, we can use a lot of planting. What's not very clear on there is we've also done a bit of an earthworks exercise where we've put a big bund in front of the site, try to sort of grade it, make sure that really a lot of that infrastructure is hidden from day one. So that is one case study. I'll just quickly hop on to the next one. And this one, whizzing through, it's near Kendal, lovely undulating landform. It's another 200 megawatt system, but we could only accommodate a 2-hour system on the site, and that's just purely down to spacing requirements. Another 400 kV connected transmission project. Again, grid costs are the same, crippling, but the capex, because we've got a 2-hour system, is reduced. As I mentioned, it's undulating landscape, it's got public rights of ways, it's got long range views, and again, without the government subsidy and no taxpayer support. So this is it. Ollie mentioned you can get green batteries, and in this particular site, because of the sensitivities of the landscape, developers do not like to do this, but we did make a commitment to use green batteries very early on in this process, because ultimately we knew it was a sensitive landscape. Not designated, I should point out, but just in terms of you can see the landform there, but you can still, however, see that there is grid infrastructure. The first photo montage clearly is existing view. Second photo montage is it would be at year 1. You might think, right, well, you've perhaps hidden the well, are the batteries hidden? I would say they are hidden to an extent. We've used the green batteries, but what we've done is done quite an extensive earthworks, civils exercise, a big cut and fill exercise to lower the site down, to use some of that excess soil and provide the screening. So again, not relying on vegetation, we're actually working with the landform and doing a cut and fill exercise as well. We have to be very careful about the drainage and existing watercourses and silt runoff naturally. Obviously, with the sites, we do try and provide a significant habitat creation and biodiversity net gain, particularly on this site because of where it's located. Construction vehicles was a key consideration too, particularly abnormal loads. Normally with the construction traffic, batteries can come on just regular HGVs or low loaders, don't require any abnormal load assessment. With the likes of some of these big transmission connected projects, abnormal loads can become a bit of an issue. That's just to do with the transformers and the switchgear associated with it, particularly at 400 kV. They're quite big. And so again, agricultural land was a bit of an issue on this one. So next slide, please. This is just an overview of that particular layout. It's not very clear on this one. It's not an engineering detail, but you can see perhaps on the northern edge of the platforms that's where a bit of a cut's taking shape. It's a slightly different coloured green. And then you can see the layout of the batteries themselves. You can see that big bit of switchgear and transformer equipment to the east of the site, the overhead lines as well, and we'd just be connecting into the Middleshore substation, or the Hutton substation, which is just opposite the site, again at 400 kV, as I mentioned. We've got the attenuation basin, so we always factor in drainage into our designs. We've got the planting, the mitigation. We've got one point of access, one main point of access, which travels southwards. It just goes off the page, but we do have an emergency access at the northern end, where that red pylon is. You might be able to see some sort of hatching there, just coming into the site. That's an emergency access, and that's to deal with the NFCC guidance, which has ever so slightly been relaxed. So for instance, 2 points of access were always preferred, almost sort of sounded like they had to be provided in every instance. But the NFCC guidance has been updated to say that, preferential, but where they can't be provided, ensure that there is suitable access, and perhaps a loop where you can around the site. But naturally, a lot of these batteries, they are inherently very safe. I think that's one of the key considerations or issues we experience from the communities. But inherently they are very safe. They don't just spontaneously combust, and we don't really want the fire services getting involved. But that's a whole other topic.
I'm going to bring Francis in at that point, because Francis, I'm really sorry I cut off right at the end of your presentation. You had some really good points to make on that kind of rapid development of technology.
Yeah, no, that was just a consideration really for local authorities, that ultimately with battery energy storage, as we mentioned, as Ollie mentioned as well, the capacity of it, we used to be at half an hour systems, perhaps even less. That's now up to 2. And then 3 and 4 are being planned, and then actually we're looking forward to 8-hour systems too. We have to date, we've done a lot of procurement work with a lot of suppliers. There's an awful lot of suppliers out there in the marketplace. On average, a battery energy storage container, it can be about 3 meters in height, but some of the latest models that we're looking at are about 4.5 meters high. And so that's why, ourselves as developers, but I imagine lots of other developers out there, would want an element of flexibility embedded within the planning consent. I don't think that's a new concept, because particularly with onshore wind, we had the was it the Rochdale envelope? Someone could come and correct me on that one, but just in terms of the assessment parameters of work, and you assess on a worst case basis, and then in the future, depending on your final choice of supplier, it gives you that flex post consent to, because there is a hefty procurement process that you have to go through. So, what might be an opportunity is working in parameter plans, so agreeing some sort of flex within the consented layout, and there might be a planning condition attached to it to say, please submit your final approved layout. A lot of our schemes are consented on a 3.5 meter height basis, but what do we do now that battery systems are looking at 4.5 meters in height, and actually they're really good value for money too. So we want to deploy this quickly. Do we want to get embroiled in section 73s and variations? That's probably a key consideration during the planning phase. I mentioned color specification too. A lot of them are white, but you can get green ones. It's just, if you're forcing someone to take a green battery, it's not guaranteed that that's going to be delivered in the future, because ultimately they might be extortionately expensive at that moment in time. You might not be able to get any green batteries. Obviously, supply chain issues are going to get really tight in the future as well, with this rapid deployment of all this low carbon and renewable energy. We're talking about 5-year implementation windows as well, plus because of the impact of connections reform. And I don't think we haven't really touched on that in today's call, but we could, do a whole other session on that in itself. But essentially, connections reform, whilst it's been an all-round good thing for the industry, clearing out projects which essentially haven't got any chance of coming forward and prioritising those projects which are ready, there are delays which are just been issued, in the past sort of couple of weeks, and even yesterday, I think another delay from NISO on connection dates. So developers will be seeking longer implementation windows. And I probably don't need to touch on the NFCC guidance as well, because that's already been spoken about today. But yeah, there was probably key things that developers will be asking in the course of planning submissions and during the determination.